Good day, viewers. Welcome to my YouTube channel. Today we'll be treating the topic parabola. So, what is parabola? A parabola is a curve in which points on the curve is equidistant from a fixed point called the focus and a straight line called the directrix. So what that means is that there is a directrix and then there is a fixed and there is a point called the focus. The directrix is a line, but the focus is a point. So the parabola is a curve, so there is a point that moves on the parabola. So the distance of that point to the straight line and the distance of that point to the focus is equal. So that is why they use the word equidistant. So now we'll be looking at the graphs, but let's look at the formula. So the formula for parabola is y is equal to 4as. Y squared is equals to 4as. So this is one of the formula of a parabola. So we'll be looking at how did they get this formula, how was this formula generated. So that is what we'll be looking at. So now, and also we'll be looking at the parabola which the vertex is at the origin. So we'll also look at the one that is not at the origin, but for now let's focus on the one that is at the origin. Once you understand the one at the origin, the one that is not at the origin is not difficult to comprehend. So now this is our y axis, this is our x axis. So this is y squared equals to 4as. So this is a parabola which the vertex is lying on the horizontal axis. So it's something like this. So it opens on the x-axis because the y is the y that is being squared. So this is how it opens. So we have the point that moves on the curve. So the point is labeled s, y. So that is this point. So let's define our focus. So the focus could be a point here. Let's say A. So you know the focus is a point, so it has the y coordinate. So it is the coordinate of the focus therefore is a, 0. Then the directrix is also on the x-axis. It has the same distance as, like, it is just like the A now. You know the A starts from the origin, like from the origin to this point is what we call A. So the directrix also have that same distance but to the left. So that will now be minus A, the negative of A. Okay, so now we draw a line across it. So this is what we call the directrix. So the directrix is on the x-axis and then it is a line, it is equals to minus A. So that is the directrix. So we are the definition of parabola says that the distance of that point that move on the curve to the focus, the distance to the focus is equal to the distance to the directrix. So this is the directrix. So as at this point, the x coordinate is minus A, while the y coordinate remain y. So it is just on this straight line. So at this point, y remains y. So here the coordinate is a, 0. Let's just put a, 0 here. So because of that definition, okay, let me label this part as z and q. Here is f. So we are saying the distance of, so yes, so the definition says that the distance of the directrix and the distance of the focus from the point to the focus is equal to the distance from the point to the directrix. So let's calculate distance. So the distance of PF now will be, using the definition for distance, that is s minus a squared plus y minus 0 squared, you put a square root, equals to pz now to be s minus a all squared plus y minus y, which is actually 0. So this will be s plus 2 squared. This root will cancel this root if you square both sides. So we have this now plus y squared equals to s plus a squared. So make y the set of formula. We have s plus a squared minus s minus a squared. So expand this, you have s squared plus 2as plus a squared minus into brackets s squared minus 2ax plus a squared. So if you open that bracket now, you get minus s squared plus 2as minus a squared. So this cancel this, so you'll be left with 2as plus 2as, so that will give you 4as. So you could see that now, that y squared is equal to 4as. So that is how they get the formula. So this is how the formula is being generated. Okay, so that is it. So the most important thing you must remember this: we have the vertex at this equation to be at the origin. We have the focus to be, the focus is at a comma 0, and then the line of directrix is s equals to minus a. Okay, so that is what you need to know. So this equation is y squared is equals to 4as. All right, so yes, there is another thing we call the latus rectum. The latus rectum, it is all about the distance from this, maybe from this point to this point. So the distance is a straight line. So it's a straight line like this. So that is what we call the latus rectum. So this one, the latus rectum has a formula. It is 4a. That is your latus rectum. It is 4a. So how do we get 4a? So at this point, let me remove what is on the screen so that we will have space to. All right. So how do we have 4a? So you know, at this point on the focus, s is equal to a, right? And the equation of the parabola has been gotten to be 4as. So if I insert the value of as there, I'll get times s. This will give me 4a squared. So what is the value of y? Y is the square root of 4a squared, which is 2a. So you see this line, this is 2a, this is also 2a. So if you add them together, you get 4a. So that is how they get the 4a. So that is what we call the latus rectum. Alright, let's look at another condition where the equation, we have another one where the equation is given as y minus k squared equals to y minus k squared equals to 4a into s minus h. In this case, the vertex is not at the origin, it is at h comma k. What happened is that your graph has shifted from the origin to a point h comma k, and this is what it means graphically. So if I have h here and I have k here, so what happened is it has shifted from this origin to this point. and that is where you have your curve. Okay, so then you discuss the same thing. So let's do that. So I will try and solve it as if it's at the origin now. So we have this. So this is still the A. The same thing that we did before remains, and just that it shifted to this point. So this one is minus A. You know that is where the directrix is. So this is your points S comma Y. So we calculate this distance and this distance. So now this is now the new origin. This is the origin 0 comma 0. It just shifts. What we have now just shift away from the origin to this point. So now to calculate your focus, so the focus is from this origin. It is from this origin to this point A. You know, from here to here is, let me use a different color. From this point to this point, it is A. This whole place is A. While from this origin to this point, the whole thing is H. So your focus is just, you are adding, that is exactly what I explained, that it has shifted forward by H plus K. So you are just adding, originally the focus is A comma 0, you get. So but for this case now, since it shifted by, it is, the whole thing has been shifted by H and K, so you just have to add it to what you have before. So now your focus, your new focus will be A plus H comma K, comma K, because you can see that the K value originally was 0, but now it's not 0 again. You could see where the focus is now. This is where it is. So the S coordinates at this point, you have to add H and A together. That is H plus A. While the Y coordinate is K. So that is why it is like this. So for your directrix now, your directrix is, you also add the H to the minus A to get the points. You know, looking at it now, the whole of this is H. You understand? Starting from the origin to this line, it is H. While this backward now is minus A. So for us to get the coordinates of the directrix, we just need this middle point. You don't want, we just need this middle point. So which will just be H minus A, because we are like going backward. We are taking away A. We want to remove, we are removing minus A from H. We are going backward by minus A. The same distance, you know, the focus move forward, like the focus is at A now. Directrix is at minus A. The same A that is there, that is what you have here, minus A. So to get this little distance here, you need to subtract this distance you've moved backward from H. So that is why the directrix S now is minus A plus H. But the point is, whenever you have your vertex to be away from the origin, you just have to add those new coordinates to what you have before. So the focus before was A comma 0. Now you add H and K to those coordinates. To the Y axis add K, to the S axis add H. Then the directrix doesn't has anything to do with Y before, only S. It is S equals minus A. So now you just add H to it, and that is all. So at the end of the day, we have Y squared. So that is how we have the whole of this. Okay. So what is the most important thing now? If your, in summary now, if your vertex is not at the origin, your equation will be given as y minus k squared equals to 4a into s minus h, while your focus will be at a plus h comma k, while your directrix will be at what? At s minus a plus h. Okay, now just in addition to what we've discussed, you know, the equation is given as 4as, right? Now your a could be positive or negative. So if a is positive, Like positive meaning a can be 1, 2, 3, and so on. So this is how your graph will look like. This is at the origin now, so it will face this part a like that. Then but if a is less than 0, that is a is what? Negative. It's taking negative value. Your graph will face this side. Sorry, to face this side, minus a, so on and so forth. So that you understand, when you have a negative value attached to this, you know what it means graphically. So that is it. And also, in addition, if I have s squared is equals to 4ay, the equation of parabola can also be written as this, but in this case it's the same thing. So now we have the s to be squared, so the y is not squared again, the y is on the other side. So how will your graph look like? So it's going to sit, the vertex is going to, diagram will look like this. But this one is when a is what? Greater than 0. When a is less than 0, the whole thing will face down. So this is how it will look like. Okay, so that is all. So in our next example, we'll be looking at how to so we'll be doing an example now on how to find the focus, the directrix, and to sketch a graph of what you've done. So we look. All right, so let's look at the following examples on parabolas. So yes, the first question says sketch the following parabolas showing the foci and the directrix. So solution. So to draw your parabola, so the first one is y squared is equals to ax and 8x. So yes, this one, the vertex is at the origin because it's clearly look like the one of y squared is equals to 4as. So the vertex is at the origin. So what is the focus? The focus is a comma 0, and then the directrix is x equals to minus a. So in this case, we just need to get our a. So we compare the 4a, we equate it to the 8. A is equals to 8 over 4. That gives you 2. So it means that the focus is 2 comma 0, and then the directrix for the given equation s is equals to minus 2. So if you put that on the line, trying to draw that, so we have the parabola y squared, so it goes to go like this, and then you have the 2 here, you have your minus 2 here, and then you rule this to be your directrix, and then this is the point on the parabola. So this is a straight line that touches this, and this is the distance. So this is the drawing of the parabola. All right, so moving on to question 2, we have y minus 5 all squared is equals to minus 24x, I think, minus 3, minus 6. So if you look at this equation, you will clearly see that this one is not at the origin. So this one looks like this formula: y squared is equals to 4a into x minus h. So, and then this one, the vertices is at h comma k, and then we said the focus will be at a plus h comma k, and then the directrix will be s equals minus a plus h. Okay, so now let's get the values. K is 5 from here, and h is 6 from here also. So let's get our a. We do 4a is equals to minus 24. So a is equals to minus 24 divided by 4. That will give you minus 6. So your focus will be minus 6 plus 6 comma 5. That is 0 comma 5. Then your directrix now will be to be x equals minus 6. Okay, no, a is minus 6, so and then there is a minus here, so that is minus 6 plus h is 6, so this will give you 6 plus 6, which is 12. So this is the directrix. So drawing the diagram now, so you start from the 2 points, which is h is 6, the other one is 5, so the parabola will sit on that. So your a is minus 6, so we have 6 here. So because a is negative, your parabola will face the back like this, to face the back. Okay, so the directrix, so the distance from the origin to 0, so minus 6, I think it should be here. So your a should be here. So this is your a, this is where your minus 6 should be. So this plus this gives 0, and then the directrix is 12, because this is also 6, so it's 12. This is 12. So this is s at 6 though, so starting from 0 to here you have the total of 12. So that is the diagram. So let's look at another example. So example 2, find the equation of the parabola with the following focus and directrix. So for the first one, we have the focus to be 2, 1, and the directrix to be s equals minus 3. So what is the equation of the parabola? So now we need to ask ourselves, what is the vertex of this given point? So is the vertex at the origin, or is not at the origin? So there is a trick around this thing. See, if the focus is a, 0, the directrix is meant to be s equals to minus 6. So it is what they give you here. It is the negative that will be here. If this is minus 5, this will be 5. So when you have this kind of thing, that is when the vertex is sitting at the origin, and then you use this equation for s. But with this, look at it, the directrix is on the x-axis. This is 2, this is 3. They are not the opposite of themselves. So that is to tell you that the vertex is not at the origin, is at the point h, k. And with this, the equation will be given as y minus k squared is equals to 4a then s minus h. Okay, so what we need now, we need our a, we need our h, and we need our k. So also with this equation, the focus is given to be a plus h comma k, and the directrix also have a formula which is minus a plus h. So they give us the focus, so we just compare them. So we have a plus h like that is equal to 2, and k is equal to 1. We also have from the directrix a plus h is equals to minus 3. So we've gotten k. So to get a and h, let's put these two things together. Call this equation 1, and this other one, we call it equation 2. Now you add them up. This will give you 2h, solving simultaneous equation minus 1. It means that h is equals to minus 1 over 2. So with this, a plus h equals to a plus minus 1 over 2 equals to a is equals to 2 plus 1 over 2, which is 5 over 2. So we've gotten a, we've gotten h, we've gotten k. I think we are ready to write our equation. So k is 1. So you put 1 here. What is a? 5 over 2. What is h? Minus 1 over 2. 2 cancel 2. You get 2 times 5. That is 10. Then x plus 1 over 2. So therefore, the final answer is this equals 10 into x plus 1 over 2. And that is for the first one. So the second one is that. So the second question is the focus was given to be minus 3, 0, and the directrix is also on the x-axis is equals to 3. So you could see this one, the opposite, this is minus 3, the directrix is 3. So that is to tell you that the vertex, and also there is 0 here. That's to tell you that the vertex is at the origin. If it is at the origin, the equation is given as 4as, and the focus is known to be this. The directrix is known to be minus a. So the point is, as long as this is 0, you can see this formula now. If this is the focus is 0 on the y-axis, a is on the x-axis, then on the directrix you have minus of what x was in the focus. That is when you know that it is on the origin. So this is actually on the origin. So what do? We just need to get our a. So you could see that the focus is the one that houses the a. So in this case, our a is minus 3. So y squared is equals to 4 times minus 3x. So that is minus 12x. And that is all. Thank you very much. See you in the next video.